Hello guys, my name is Chase Engel, as you all probably know. And today I'm going to be talking about how a pressure cooker works. Shout outs to Mr. Johnstone for letting me use his classroom, and shout outs to Miss V for this project. Alright, so first, I want to talk about what a pressure cooker is. Um, so a pressure cooker consists of the following things usually. There's a pot, um, a rubber ring, which we'll talk about its use later, a lid, a whistle to indicate the steam, a pressure indicator, which is also important, and of course a handle. The pressure cooker is used to cook foods um, much faster than a your typical pot would. It was invented by a French guy named Denis Papin, if I'm pronouncing that correctly, in 1679. But it became popular as a consumer item in America in the 1920s, during the Roaring Twenties and this rise of consumerism. Shout outs to A Push for teaching me that. Anyways, so we're gonna be talking about gas laws and how that allows the pressure cooker to actually work. So over here, how does it work? So this is the equation we'll be referencing to understand how it works, specifically the pressure and the temperature in our ideal gas law. We don't have to worry about the volume or the number of moles or whatever, because those aren't a changed variable in the pressure cooker. So let's say you have your regular pot. Your regular pot, although you can put a lid, it doesn't really insulate the heat or the pressure. So the boiling point will reach 212 Fahrenheit, and it won't really go above that because if you boil water more, the heat escapes and it doesn't get any hotter than 212 degrees. It'll just cause more vapor to form, allowing more steam to come out faster. So it never goes above this temperature of 212 degrees. In a pressure cooker, where you have the lid and the rubber ring insulating the heat, as well as a pressure indicator to show the pressure inside due to the temperature rising, because as the temperature rises, the pressure will also rise, because both sides of the equation have to be equal to what it was before. So if you increase the temperature and there's no other variables to change, then the pressure also has to increase. So in this container, in the pressure cooker, the heat is building and so is the pressure. So what that does is you might have your little food in here, maybe your garbanzo beans or whatever you want to cook in here. It should go well with water because whatever you're cooking does need to sit in water, unfortunately, but that's just a drawback of the pressure cooker. But what happens is by by insulating this and having the temperature raise and the pressure raise also, the temperature of the water can actually reach 250 degrees Fahrenheit. And although it won't go any higher than that, that means the food is going to cook longer. So the pressure is rising, and so does the temperature that the water can reach. Because as this pressure is pushing down on the water, what happens is the water has a harder time releasing itself into vapor or steam. And so it has to get to a higher temperature in order to overcome that pressure. You also might be thinking, well, why isn't the food being crushed due to all this pressure inside? That's cooking it so much faster. Well, the this is interesting. The steam actually distributes the pressure on the food quite well. And what happens is it makes sure that it doesn't completely crush the food. You might compare that to, let's say, someone stepped on your foot with just like a flat shoe. That's not going to hurt too much. But if they step on your bare foot with like a heel, that'll hurt more because the pressure is being exerted in a smaller space. So yeah, that's how a pressure cooker works and cooks your food faster. Very handy kitchen tool. Yeah, thank you so much. Have a wonderful rest of your day, and I hope one day you get to experience how to use a pressure cooker.